today's video, I would like to introduce a very nice problem of Polish Mathematical Olympiad edition 1994-95. Here is the following setup. Find all x and y as natural numbers such that we have this. Actually, there is a bunch of ways to solve this one, which means y divides x plus 1. According to the congruence definition, so this one equivalent x plus 1 is a congruent to 0 mod y. Okay, this is first thing. The second thing, I'm going to work on the second fraction. Second fraction, we have x divides y plus number 1 according to the divisibility statement definition. So we will have y plus number 1 equals n is multiplied by x, where is the n is a sum natural numbers. Okay, I'm going to move number 1 to the right and leave y to the left. So we'll have nx minus number 1 equals y. Okay, this one is a congruent to 0 mod y because y divides y. Let's name as a first statement. This is the first statement, this is the second statement. Okay, by adding 1 on 2, I get x plus number 1 plus nx minus number 1 is a congruent to 0 mod y because both statements are mod y. Okay, so I will have a nice cancellation here. Number 1 will be cancelled out with number 1. Then I will have x is, then by taking x as a common factor, I will have x is multiplied by 1 plus n is a congruent to 0 mod y. Okay, this one is telling us, according to the divisibility statement, y divides x or y divides n plus number 1. Okay, we have y divides x plus number 1. Okay, this one is telling us but y not divides x. Okay, because x plus number 1 and x are prime numbers. Okay, so as we have here, since y not divides x, which means y must be divides n plus number 1. Okay, so according to the divisibility statement, so this one equivalent n plus number 1 equals n equals m is multiplied by y, or is a m is a sum natural numbers. Okay, so I have this expression and this expression. Okay, so by inserting y into this one to find the combination between this equation and this equation, which means I will have n plus number 1 equals m is multiplied by nx minus number 1, nx minus number 1. Okay, this one equivalent m equals n plus number 1 is divided by nx minus 1. So dividing both sides by nx minus 1, so it's clearly if nx minus 1 is different than 0. Okay, which means nx must be different than number 1. Okay, in order to avoid 0 in denominator. Okay, because we have a restriction here. This implies n plus number 1 is superior or equal to nx minus number 1. Okay, by moving this minus 1 to the left and bring over n to the right, I will get 1 plus 1, which is 2, is superior or equal to nx minus n. By taking n as a common factor, I will get n is multiplied by x minus number 1. So in the other words, n is multiplied by x minus number 1 is inferior or equal to 2, like this. So I have ended with this following inequality, which means this product must be equals to 1 or equals to 2. Okay, this one is telling us n is multiplied by x minus number 1 equals either 1 or 2. Let's take first option, which is if n is multiplied by x minus number 1 equals 1. Okay, one equivalent n equals 1 and x minus number 1 equals 1. equivalent n equals 1 or x and x equals 2. So I found n equals 1 and x equals 2. As we know, we have a relationship between y and x, which means by inserting x and n, by inserting this value of n and x into first equation to find y. So this one, it's simply telling us y equals nx minus number 1. N will be replaced with 1. X will be replaced with number 2, which means I will have 2 minus 1 equals 1. So I have the first pair of the solution, which is x equals 2 and y equals 1. Okay, to work on the other possibility, if n is multiplied by x minus number 1 equals 2, equivalent n equals 2 and x minus 1 equals 1. Okay, or the inverse, n equals 1 and x minus number 1 equals 2. Okay, equivalent x equals 3. So I found the value of x equals 3 with always n equals 1. Okay, so by taking this value of x and insert it into the first equation to find another pair of the solution. Okay, which means y equals nx minus number 1. Nx, which is 3, is multiplied by 1, which is 3. I will have x equals 3. Y, I'm going to insert this value of n and x into this equation, which means n equals 1 is multiplied by 3, which is 3. 3 minus 1, which is 2. So I'll have another pair of the solution, y equals 2. Then this is the first, this is 2 pair of the solution. But in case if we have n, but we have another case left, as you know, we have a symmetry here. If x and y equals, so we forgot to check another case. What about if x equals y? If x equals y. If x equals y, I'm simply going to replace y with x here. So this one, equivalent x plus number 1 equals nx. Okay, so by moving over x to the right, I will get x is multiplied by n minus number 1 equals 1. Okay, so since this product equals 1, which means x equals 1 and n minus 1 equals 1. This one is telling us equivalent x equals 1 and n minus 1 equals 1 is equivalent n equals 2. If n equals 2 and x equals 1, I'm simply going to replace this information into the first equation to find y. Okay, so which means I have another pair of the solution, y equals nx minus number 1. Nx, this product is going to be number 1 is multiplied by 2, which is 2. 2 minus 1, which is 1. So I have the pair of the solution x equals 1 with y equals 1. So I found these 3 solutions. Okay, don't forget we have a symmetry here, so I'm going to take this pair of the solution and make the copy of this one. So I will have the solutions will be the following. So we'll have the first solution, I will have x equals 2 and y equals 1. So by symmetry I will have x equals 1 and y equals 2. Okay, here is the first pair of the solution. The second pair of the solution, as we have x equals 3 and y equals 2, which means I will have another pair of the solution which is x equals 2 and y equals 3 by symmetry. So the other one, it's clearly x equals 1 and y equals 1, which means I have 5 pair of the solution for this one. I'm going to finish off with this one. I leave the next method to you guys. You can check it. Just let me know in the comment section below. Okay, so I have done with this problem. If you have any question or suggestion, just put it in the comment section below. Thank you for watching. I will see you in next video. Bye.